This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
Okay, there are two more examples left for today. We are going to see the usage of MODULO operator in this example. So again, let me write it. That 7 divided by 2 in terms of programming are 3, and 7 modulo 2 is 1. Since when 7 is divided by 2, the remainder is 1. And the quotient is 3. I told you that everything the machine understands are binary numbers, zeros and ones. Okay? So 1 0, a 0 or a 1 is called a bit. Okay? And here I have how many bits? 8 bits. And 8 bits make a byte. 1 byte is 8 bits. Then we have 1 kilobytes. There are 1024 bytes, not 1000 bytes. It's 2 to the power of 10. Then we have 1 megabyte, which is 1024 kilobytes. And we have 1 gigabyte, which is 1224 megabytes. Something bigger than gigabyte? Metric bigger than gigabyte? Terabyte, which is 1024 gigabytes. Okay. Now, in this program, what are we doing is the following stuff. As a comment, by the way, you can read what I just explained to you. Let me explain to you briefly what is this program doing. In this program, we want to estimate the time we need to download a certain file. Okay? The size of the file will be the input, and the connection speed will be also the input. And we should calculate the time we should download the file. Okay? So let's run the program first. Let's see how it's working. I suppose everyone has internet at their home, the campus. Do you know the speeds of the internet here?
1 kilobyte per second.
1 kilobyte per second. Come on, it's not that bad. Officially, I think it's between 10 and 20 megabits per second, but I'm not sure. By the way, so we want to compare ADSL or fiber optics. This is a symmetric digital subscriber line. You probably have it, or fiber optics or cable, whatever. They're not the same, but the speed is high. Usually, let's say 10 megabits per second. And if we talk about dial-up, probably when you were not born or when you were like 3 or 4 years old, I remember I was using dial-up, and the speed was 54, if I'm not mistaken, kilobits per second. Pay attention, this is not byte, this is bit. Byte is written as uppercase B. And if you have lowercase b, it's bit, meaning a 0 or a 1. Okay? One binary digit. Now let's assume that our file that we want to download is 70 megabytes. Megabytes, yeah. It might be a video or whatever. So, what is this program doing? Enter the file size in megabytes. It's 70 megabytes. I'm entering it. Enter the connection speeds, the speed in bits per second. Now we have 10 megabits per second, and we should enter it as bits per second, okay? Not megabytes. We can approximate here that 1 kilobits, it's not kilobytes, kilobits, it's 1,000 bits. Then that one megabit is approximately 1,000 kilobits. So if you want to find this stuff here, this is 10 multiplied by 1,000 kilobits, and this is 10 multiplied by 1,000, again multiplied by 1,000 bits per second. How many zeros do we have? 1, 2, 3, 4, 5, 6, 7 zeros. The program is asking this as an input, bits per second, and we have 1 with 1, 2, 3, 4, 5, 6, 7 zeros. This is what we get. So the estimated time for the download of 70 megabytes of file on 1,001 million? No. 10 million bits per second line is 0 hours, 0 minutes, and 58 seconds. Okay, so for 58 seconds approximately, you should download the file. Let's check it. Let's run the program again. So the file size is going to be 70 megabytes, and we are using dial-up. And dial-up has 54,000 thousands of bits per second. Let's see with dial-up how it's working. You'll need 3 hours, 1 minute, and 40 seconds to download the same file. So the internet back then was very slow. I'm talking about 15, 20 years ago. Okay? I remember that I used to use dial-up, and it had 54 kilobits per second. Imagine it was slower than that. Because you know, service providers say, okay, you have an internet of 20 megabits per second. And if it's actually 10 megabits per second, you should be happy, usually. Okay. Let's see how this program is working. Again, I'm going to play the role of the compiler. So, let's go line by line. We are declaring the first commands, file size in megabytes and connection speed. Those are integer variables. This is what the compiler is doing. Reserving boxes, reserving memory for file size, MB, and the other one is connection speed. Those are integers, by the way. Again, everything is about integers. Okay. We have time, hour, minute, second, what else? Size in bits. Now, before proceeding to the calculations, let's do it in classical way, without using programming. So let's say that I'm giving to you the size of the file, and it's 70 megabytes, and I'm giving you the connection speed. It's either 10 megabits per second or 54 megabits per second. Can you do the math in order to calculate how many hours, minutes, and seconds you need to download that particular file? Can we do it? I mean, it's easy, but is there any hero that can come and do the math or not? I can give you a hint. you can use the modulo operator, the remainder. More hint, if you have the file size and the connection speed, then time, this time here, will be file size in megabytes divided by connection speed. Okay. Since this is given in bits per second, this will be in seconds. Okay, so it will be something like this is in megabytes. Let's say x megabytes divided by y bits per second. Bits per second, which is, we are going to convert this into x prime megabits, or bits, from megabytes to bits, using this formula here. This data here, divided by y bits per second. Bits and bits go, so we have seconds. So basically, first we calculate the time, the overall time in seconds, and afterwards, if you know the time in seconds, you should calculate the hours, the minutes, and the seconds you need for that. Because it might be 10,000 seconds. Okay? So we have at least 2 or 3 hours. And how many minutes and how many seconds? How are we going to do that? I think if I show the math first, like this one, it will be much easier for you. I hope I have the calculations here. I really hope I do. If not, we're going to do that. So, let's say, let's do the calculations. Time is equal to file size in megabytes. Okay, 70 megabytes is equal to 70 multiplied by 1024 kilobytes. And this is 70 multiplied by 1024 multiplied by 1024 bytes. And this is 70 multiplied by 1024 squared, because we have 1024s, multiplied by, we want them in bits, multiplied by 8. Bits. Why we are converting megabytes to bits? Because the speed here is given in bits. Okay? That's why we're converting megabytes to bits. So, how much is this stuff? If I'm not mistaken, if my calculations here are correct, I hope they are. We have here 58 million 72,100,000 no, I think it's 50, just a moment. So we have 0, 6, 5, 0, 6, 5, 202. 587. So 587 million, approximately 87 millions of bits. While the speed, if it's 10 megabits per second, it's going to be something like 10 multiplied by 1000 multiplied by 1000 bits per second, and this is only bits. When everything is going to be divided, I think I have here 35 seconds. I might be wrong. I mean, I'm just showing you the way we should do it. So we know we have here 35 seconds. This is the overall time. How many hours is this? 0 hours, 0 minutes, 35 seconds. Okay? let's imagine that we are using 54 kilobits per second, meaning 54 bits per second. So instead of this stuff here, and I'm going to raise it, let's imagine, I hope I'm not wrong with the maths, but in this case, I'm trying to emphasize the way we're going to calculate hours, minutes, and seconds. I'm not trying to be exact. Let's say that we have here let's make up a number. This is not the case, but let's say that this is 10,056 seconds. So obviously we have minutes here, we have hours. How are we going to find this stuff? An idea? You might think for a minute or so.
For an hour, we should divide 36,000.
Exactly. Why? Because 1 hour has 3,600 seconds. Okay. So when we divide this, so hours will be time. Let's say time here is 10,000. And 516. Okay, so hours will be time divided by 3,600. Since hour is an integer variable, it will discard the floating part, the decimal part, and the whole number, the integer part, will be written in. Okay, so how much is that? Let's divide. Let's do the maths. So we have 10,5600 divided by 3,600. And this is 2 hours. Okay, so we have 18. What are we going to do next? How are we going to find the minutes? So far, so good.
Divided by 3,600.
Which one? So we want to find the minutes. So minute is equal to, yeah, you can try.
1 hour equals to
Yeah.
3,600.
Yeah. So we have 2 hours. It's approximately 7,200. You can subtract what? This from 7,200, and then with the minutes, how are you going to do it? You do what?
The remaining.
The remainder, yeah. Try to use this one. This is the modulo operator. Maybe you can look at the code different, but yeah. If you divide time with, since 1 hour is equal to 3,600 seconds. If you divide this and this, and you get the remainder, what does that mean? I mean, basically what we want to do, out of 10,000 seconds or so, we want to take off 2 hours. And how are we going to do that? In order to see how many more seconds do we have. You can do it like this. 10,000 minus 2 multiplied by 360. Okay? But isn't that the remainder? So, let me write it. We have 7 is equal to 2 multiplied by 3 plus 1. This was the quotient, if you remember. This was the remainder. Okay? So we are looking for the remainder. How can we find it? maybe this math is maybe a bit more complicated. Maybe you would like to do it something like this. So minutes is time minus hour multiplied by this stuff. And here we have how many minutes do we have? It's left, okay? This is clear. So time is 10,560 minus 2 hours, which is 7,600. We are left with what? Let me check it. 72. This is this much. But this is still not correct. This is in seconds, and we want to convert it to minutes. So what do we do? Again, divide by 60 here, divide by 60, and we can get the result. Okay, the result. But we are not using the modulo operator. And think if we do something like this, minute is equal to time. I mean, this is not about programming. This is pure math. If you know the maths, it's very easy to write the code. Okay? Minute time modulo this stuff divided by 60. Yeah. Because with this stuff here, you will get this one. You see, how do you get the one? You get it. 1 is 7 minus 2 multiplied by 3. And here you get it time, which is 7, minus hour multiplied by, okay? And afterwards you divide it by 60. Did you get the how many of you did? Very nice. So we have the formula for the minutes. What about the seconds? Yeah, you might go subtract hours time to multiply by 360. The minutes, I think the number of minutes is, I don't know. Let's say, I'm making them 50 minutes. Then 50 multiplied by 60, you subtract what is remaining from this one. And what is left is the seconds. But there's another easy way of doing things. That's why we're using modulo. Instead of multiplying and subtracting, we're just using the modulo operator. It's the same for the seconds. How are you going to do that? I mean, from this time, when everything will be put here and here, the seconds are what?
Minutes and remainder.
Exactly. So it is just right here. But if I see your logic, you're right, but you can do that stuff after you subtract the hours and the minutes and what stuff is the seconds, or you can immediately use the modulo operator to find the seconds. You can do the math at your home because it will take me like 10 more minutes. So the seconds will be time modulo 60. Because for sure, you will not have more than 60 seconds. If it's more than 60 seconds, it will be put here, okay? Basically, the logic is the following. What can we put at hours is put already. What can we put in minutes is put already. And what is left is the seconds. Basically, this is when the time is divided with 60. The remainder is the seconds, okay? Because we couldn't put them in minutes or hours. So this is the math that we are going to use in our program here. Okay. Let's go and see I'm going to write the output. Okay, this is another formula. Time is file size in megabytes divided by connection speed. I hope we don't need this part here. Can I delete this? Okay, I'm deleting it. Well, let's see the output. This is what you will get as an output. Okay, we have done this stuff. We have reserved memories. Everything is empty initially. So this is done with the first lines of the code. Then we are printing enter the file size in megabytes. Enter the file size. Let's say that we enter 70 as our input, and 70 will be put here. These are all integers, by the way. Enter the connection speed in bits per second. So enter the connection speed. You might change this part here, the code, and I'll give you like 5 minutes. So you can enter the connection speed in, let's say, megabits per second, or maybe kilobits per second. But let's see how it's working for the time being. Well, let's say that I'm giving 54,000 as an input. So we'll have here 54,000. What I'm doing, I'm converting the file size in bits. And as you know, it's file size in megabytes. When I multiply it with 1024, it's kilobytes. Again, when I multiply it with 1024, it's bytes. Again, when I multiply it by 8, it's bits. And this is bits in seconds. They should be in the same metric. So I'm calculating size in bits. And let's say how much do I get? I get approximately something like this. Approximately. With how many zeros? 7 zeros. Okay. This is size in bits. Afterwards, I'm calculating the time. And as you can see, the time is file size. This is a megabyte, but we converted it to bits. So it's file size divided by connection speed. Size in bits divided by connection speed. The hours are time divided by 26. This is it. Minutes. Time modulo 3600 divided by 60. And we have the seconds time modulo 60. This is that formula. Finally, the estimated time for the download of blah 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 is going to be printed. The estimated is of file size in megabytes is 70. We're going to print 70. Megabytes file on a connection speed, it's 54,000. Line, bits per second line is, and when we did the calculations here, I forgot, of course, time is equal to this, hour and minutes. We put the corresponding times, let's say it's 10,050. I'm making the numbers. The math might be wrong, and I think it's wrong. But it's easy to do it. Let's say this is 3 hours, 56 minutes, and 36 seconds. So we calculated that stuff here, and now we're just printing hours, minutes, and seconds. So it's 3 hours, 56 minutes, and 36 seconds. This is it. Questions? All right. Should I run the code again for you or not? Let me run it again. So give the size file. Let me give a bigger file, like let's say 500 megabytes. The connection speed, let it be 16. No, it's not 16. Again, 54,000. That would be dial-up connection, bit per second. So, wow, there's an interesting mistake. I'm going to tell you. So I need minus 31 minutes. We're going to see in the next example that this is a good mistake. And we're going to see why did we get this mistake. Just imagine time running backwards. So instead of you growing, you're becoming younger and younger, eventually a child. Okay, you become a child. Isn't that cool? So the file size is going to be 500 megabits, and let's say the connection speed is 16 megabits per second. So I have the same mistake for the same reasons. And I'm going to tell you why. Let me make it 50. And the connection speed is this much. So I need just 41 seconds, okay? If it was 50, the connection speed is this much. I need 12 minutes and 56 seconds, okay? You can check it for hours also. I'll give you like, I don't think that we have time now, that. Okay. Try at your home to take as an input the file size in bits and the connection speed in megabits. Or both, this will be megabyte, but connection speed is going to be in megabits, okay? So do some conversions. You're going to change this piece of the code. Let's try it. It's going to be useful for you. Finally, why did we get negative results for the time? It's not that the time goes backwards. It's proven that it goes in forward manner as an arrow. So you should lose your hope that you're going to become younger. You'll get older by time. But let's see why did we get this kind of mistakes. As I told you, computers represent numbers in bits. Computers know, computer machines, digital machines know only ones and zeros. So whenever I say 3, it's stored as a combination of ones and zeros, okay? Let's have something like this. Number of bits and combinations. If I'm using only 1 bit, it can be either 0 or 1. So how many combinations do we have here? So our number of bits is number of bits is 1. The combination is either 0 or 1. Totally, we have 2 combinations, 0 and 1. If I'm using 2 bits, we have how many different combinations? We have 0, 0, 0, 1, 1, 0, 1, 1. You know how many? 4. Let's say that I'm using 3 bits. And these are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. You might try to help me. 1, 0, 0. You see the logic how it's going. But only zeros and ones. 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. 8. What do you think? With 4 bits, how many combinations is going to be? Guess it. 16. Why? Can we come up with a formula about this one? 2 to the?
Power of n.
Exactly. If number of bits, let's say it's n, it's going to be 2 to the power of n. 2 to the power of 1 is 2. 2 to the power of 2. So here n is 1, n is 2, n is 3. Some of your friends don't ask me what's the difference between a float and a double ball. They're the same. Technically speaking, the difference is that one of them has more numbers. Number of bits is more. It gives more precision than the other one. Okay. So this is the difference. Now, why are we doing this stuff? By the way, this is how computers see 0. This is 1. This is 2. This is 3. This is 4. Sometimes this is 5. Sometimes this is minus 2. You will see why. Okay. Let's say this is 5. Have you ever worked with binary numbers before in your high school? You'll do it during the scope of logical design, but some students have already seen binary numbers. Okay. Let me erase this stuff and tell you something interesting and see why do we make mistakes like we saw it previously. Integers. We know what integers are. And in order to represent an integer number, the computer, so when I say integer a, and I'm declaring a variable, the computer basically reserves 32 bits for that particular integer, okay? So, it will be something like this, 0, 0, 1, 0, 0, 1, 0, blah, blah, blah. That's 1. These are 32 bits. Given the number of bits, we can see that there are constraints on the number of combinations, hence the number of numbers we can represent. So at most, how many numbers we can represent with 32 bits? Okay, with 1 bit, 2 combinations. With 2, it's 4. With 3, it's 8. With 32, 2 to the power of 32. Okay? And what if I want to represent something that is bigger than 2 to the power of 32? I cannot do it. But there is another problem. Integer numbers can be negative also. So what if, and actually half of those 2 to the power of 32 combinations are positive, approximately, and half are negative. So if I divide this by 2, how much do I get? 2 to the power of 31. Meaning that 2 to the power of 31 numbers are negative, and the remaining are positive. If I put 0 as a positive number. So, what is the range of numbers that I can represent with integers? What's the smallest, meaning the smallest number, and the largest I can represent with an integer?
Smallest is minus 2.
Exactly. The smallest is minus 2 to the power of 31. Blah, blah, blah. Then we go 0, 1. What's the biggest number? Let's see whether it's the case. Plus 2 to the power of 31. 2 to the power of 3 is 8. 3 bits. 2 to the power of 3 is 8. But what's the maximum number I can put it in? It's 7. Why? Because one combination goes for 0. That's why the biggest number I can represent is 2 to the power of 31 minus 1. Okay, so remember this one. And usually it's part of your exam. Not the number, but some calculations. The smallest number is this one, the biggest number is that one. Now let's go with a new piece of code. The last one for today. today is Overflow.cpp. What is this code doing? It's very simple. You have a hard disk, let's say. You give in megabytes how many, you give as an input how many megabytes it has. As an output, you are going to find how many bits it has, okay? Basically, how you can do it. If you have this size in megabyte, you multiply it by 1024 to convert it to kilobytes, again with 1024 to convert it to bytes, again with 8 to convert it to bits. Okay? But remember this one, the biggest number we can represent is this one. So let's run the code. Let's not forget ignore. I think they should be always put. We should already have them. Okay. I'm running the code. Now let me give what? 259 megabytes. Let's say I have a disk of 259 megabytes, which is minus this much bytes. Does it make sense? No. Why? Because we have this issue, and this issue is called overflow, representing something that is out of the range. Can you tell me, also, I mean, you should know this one, just for curiosity, that 2 minus 2 to the power of 31, to the power of 31 is, I think this is 2 billion, 107 millions, 483,647 and 48, I'm sorry. So the smallest number you can represent is this one. And the greatest number you can represent is how much? The same number minus 1. I mean, in absolute values. So here's this one. Now, if the number of bits is greater than this much, it will be a mistake. So, can you tell me, and this will be counted, don't forget to assign the attendance sheet, and this will be counted as activity for you, because you know 4 points, 4% to 5% will be your grade from your attendance and activity. Okay, activity meaning you ask questions, you write code, you answer questions, whatever. Can you tell me? So this is the maximum number of bits we can represent with an integer. In megabytes, how much is that? Remember, 1 byte, 8 bits. 1 kilobyte, 1024.
Around 200?
Yeah, but mathematical. I don't want guesses here. I want something mathematical. Strict. This is number of bits. In megabytes, how much is that? Of course, we divide it by 8, by 1024, so this is the maximum in bits. Is 2 to the power 31 minus 1. Maximum value that we can give in bytes, maximum bytes is maximum in bits. Well, let me write maximum bits. Divided by 1024, again, 1024 to convert it to kilobytes, to bytes, and by 8 to convert bits to bytes, then kilobytes, then megabytes, okay? When we do the maths, when we divide this guy here with this stuff here, we will get 255. Okay, let's check it. So let's run the program. I'm giving 255. And oh yeah, I have a number that is pretty much close to this one, okay? 2 billions and blah, 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 and so on, bits. But let me give, so with 255 it's working. Let me give it with 256. You get this stuff, negative value. Why? Because you see how it's working, 0001, how they are evolving. When everything will be 111, it's going to restart from 0000, okay? Something like that. It's a kind of cycle. But you should, I mean, this is two's complement. You're going to learn this CS204, logic design, how computers represent numbers. I shouldn't bother you with that. I just want to tell you that there's something that is called overflow, and this is because we have restrictions. Let's say for integer is 72 bits. Now this is the greatest number we can represent. If you want something greater than this, we have mistakes. Okay? And if you want to know exactly what's going to be the mistake, you should know what's 2's complement and how it works. For the time being, just you can assume that it doesn't work if there's something wrong. Yeah.
The professor said something about you showing us how to submit homeworks.
Yeah, we will do it in a while. Just let me show you another example, very briefly, and I'll take like 5 more minutes for homeworks. It's very easy. These are integer numbers. Integer numbers have negative and positive values, but there is something that is called unsigned int. Erase this stuff here. You have also unsigned ints, unsigned integers. They are also 32 bits, but unsigned meaning you don't have this sign, meaning that everything is positive. So the range you can represent with those is from 0 to 2030 to the power 2 to the power 32 minus 1. There are no negative values, meaning that the smallest number you can represent with the type, which is called unsigned int, is 0. You don't have negative numbers. And the greatest value that you can represent is this one, which is approximately 1, but exactly it is 4 billion, approximately this guy multiplied by 2. 4 billion billions to 194 millions, 967,295. This is the greatest number. Now, let me do some changes in the code here. You see there's another part of code which is commented. It doesn't take it into consideration. We're going to do this stuff. We will need see and see ignore. We're going to cut it from here, put it here. Then we are going to comment out the part when we use, you see integer and integer here. We saw the example of integer. In order to comment it, you can just select the part you want to comment and go here and comment all the selected sections. If you want to uncomment it, select the part you want to uncomment, but it should be first comment it out, go here, uncomment, and this is it. You see here, you have an integer, just like here, this size in megabytes, but you have unsigned integer for this bit, for this size in bits, meaning the range is higher because these don't have negative numbers of bits. Okay, so that's why you should take care of when you're using data types. Okay, if you're sure that you're not going to use negative numbers, you should go with unsigned integers. Okay. Now let's see provisions. Let's run the code. As you might remember, previously, if we wrote something like 256, we had a mistake. But let me write 256 as an unsigned. Now we're working with unsigned integers. And you see that this size is this much. Basically, one more than this one. Okay, so it cycles around, and we had this result, minus this one. Okay? So what do you think? What's the maximum number of bytes we can give as an input here? Well, it should be this guy here, the maximum value. So it's this guy, the maximum unsigned, the maximum value that unsigned integers can have, divided by 1024, again 1024 and 8, which is 5. I mean, if it was 255, this is multiplied by 2, it's approximately 511. So let's check 512 if we give it as an input, and we have 0 bits. Okay? So this is the greatest integer value that we can give, that gives us an error, but the greatest with value that we can give as an input without an error is this one. So 511 megabytes are this much bytes. Approximately, as you can see, we're approaching the limits because we are now working with unsigned integers. This is it. If you want, I can show you how to submit your homework. Let's say this is your homework. So let's say Overflow.cpp is your homework. You should change it. It should be something like this. You should rename it. First, SU course name, which is Arthur K in my case, underline, your name, underline, your surname, and then homework 1.cpp. Okay? This is it. Now, you're going to open the solution folder, which is here. This is the file that you need. You are going to compress only the CPP file for the time being. Okay? So right-click it and add to r2.zip. This is a compressed file. You have the file here. Let me take it to desktop. This is the file that you should upload. How are you going to do that? Let me tell you. I'm going to log out first. So you go to SU course, thing that you have done. You write your name. Okay. Go to SU course. It's SU course. Log in. I'm going to view it as a student. Okay, so you have the assignments here. Go to the assignments. You have homework 1. Homework 1. Go to homework 1. You should go to browse. Now let me find, this is the file that I just zipped, the CPP file. Let's open. And you just submit it. This is it. It is submitted. Probably you should get an email for the submission. Okay. If you want to resubmit it, let's say you did some changes. Again, browse the file you have zipped, open, resubmit, and that's it. Okay? But if you have more submissions, like it's the case here, you should remove the ones that are not needed. You can leave only the latest one. The penalty is 10 points. The deadline is, I think, 12th of October. Let me check. Yes. Okay, you can upload it until 13th of October with a penalty of 10 points. Again, I didn't finish. You can go if you want, but I'm going to tell you something that is important for you. Okay. This is the output, how it should look like. So, it should work something like this. Let me change the font.
So I haven't.
Yeah, you can go. You're free to go.
But you can take the attendance.
You can subscribe. Don't forget the attendance, okay? So, enter the name of your country. Let's say we are talking about Turkey. How many medals? It's 500. It's 220. 130. How many gold medals did Turkey win? I think they won 1, 3 silver, and 4 bronze medals. Okay. So you can and you calculate the percentage. Okay. So Turkey won 0.94% of medals.
May I ask you something?
Yeah.
Percentage gives 0, but I used float.
Yeah. You should use. No. There was some mistake that you did. So that's why I tried the example with integer divisions. Okay. That we did today. Check it. You did some mistake. Conversions from float. So you have the samples, the sample runs. I just showed you one. If your program works as it's given here, fine. Otherwise, some points will be deducted from your assignment. So far, so good. Class dismissed. See you next week, same time, same place. Thank you.